Okay, everyone. Hello, everyone. In this video, I will review the stuff I taught I taught on Monday and explain how to use the Google Sheet to find the correlation coefficient. Okay. So first of all, on Monday we said a bivariate data is a data that has two variables. Okay, it has two variables. The first variable, the x, is we call the predictor, and the second variable y is called response. So we have a predictor variable and a response variable. Okay. Okay. And um, the X and Y, they can they can have the following relations. The the first one is there is a linear relation. There is a linear relation between these two variables. Okay. And the second case is there is a non-linear relation. Okay. And the third case is these two variables do not have any relation. So no, no relation. Okay. And if there is a linear relation between these variables, the linear relation can be either positive or negative. Okay. Yeah. As the picture we saw on Monday, right? In the first two pictures, there is a linear relation. This is a positive relation and a negative relation. And a second one, that this is a nonlinear relation. And the last one is a no relation. Okay. And we can tell, given us a bunch of data, given us a bunch of bivariate data like this, we can tell whether there is a linear relation or not by checking the this number, which is called a linear correlation coefficient. Okay, so the result is if this coefficient is very close to +1, that's an indicator we have a positive linear relation between the two variables. And if R is close to -1, that's indicator of a negative linear relation between the two variables. And if R is very close to 0, there's a little or no evidence of a linear relation between the two variables. Okay. But things will be complicated when the R is not close to 1 or -1. Say, in this example we saw on Monday, it turns out R, after we did this calculation, R is a 0.4, right? So how can we know when we have a coefficient like this one? Okay. And then we will compare this coefficient with a critical value. Okay. If if the if the absolute value of the coefficient is greater than the critical value, then we say there's a linear relation exists between the two variables. Okay. So now I want to show you how do you find this critical value? Okay, how do you find this critical value? I'm gonna use one of the questions from the homework as my example. Okay, so first of all, I copy this data to the Google Sheet. I'm using the Google Sheet because this is available to everyone. Yeah, yeah. Because some of you use Windows, some of you use a MacBook. So, but Google Sheet is available to everyone. Everyone can access to this tool. Okay. Um, yeah. So right after we copy the data to the Google Sheet, the commands we're using is this one. Um, yeah. And after and in the inside of the parentheses, you wanna enter where you save the X value, where you save the predictor, and where you save the response. Okay. So see, so this is my correlation coefficient. Okay. So enter CORREL. Okay. Now my data, the X value saved from A1 to A12. So A1 and colon A12 and a comma. And then I want to enter where the Y value are saved. So they are saved from B1 colon B12 and press enter. Okay. So this is the coefficient for this data. Okay. Now, how do we know these data? How do we know these variables X and Y are linear or non-linear? Okay. So we're gonna compare this value with the critical value. Okay. How do you find the critical value at this significance level? Well, we're gonna use a table. Okay. And I have already posted this table to eLearning. The name of this table is this critical value for correlation coefficient. Okay, so let me open this table. Now, once you can see, they have a bunch of numbers. These numbers are the critical values. Okay, but we're gonna find the critical value we are using for our question. Okay, so how do you find that critical value? We need this significance level, which is 0.05. So we go to the top, right? This is 0.01, 0.02. Okay, this is 0.05. Now, the critical value is gonna be for this significance level are this, right? Are in these columns. Then we need to figure out the degrees of freedom. Okay, the degrees of freedom. Remember when I introduced the standard deviation? When I taught the standard deviation, I said the degrees of freedom is n minus 1, right? Here, the degrees of freedom we are using is n minus 2, right? This is the different. Okay, so how many data do we have here? Remember, each pair is a data, right? Each pair is one data. So we have one data, two data, three data, and so we have 12 data. So we have 12 data, then n minus 2 will be 12 minus 2, which is 10. Okay. This is the degrees of freedom we're using in this pressure. Then I go back to this table and this chart and find the degrees of freedom of 10 and the significance level 0.05. So the critical value is 0.5760. Okay. Critical value is a 0.5760. Okay. So what is my coefficient? 0.52. Okay. So R is a 0.52. Now because R is a here we don't need to use a absolute value because R is already being positive. But let's say if R is negative, you wanna before you compare R, you need to add you need to take the absolute value of R, right? Now because here the R is less than the critical value. So remember what does this test say? If it's greater than the critical value, then we say there's a linear relation. Otherwise, no linear relation. So our conclusion should be no. There's there's no significant correlation. Okay. Now let me do another one. Okay, I want to do a different one. Let's see. Let me do another one. Okay, so let's see. Right now, the significance level is a 0.01. So first, what we do is um, copy them here and enter A1 to A11. Okay, and B1 to B11. Okay. Okay, so this time the R is 0.86. Okay, 0.86. And what is my degrees of freedom? So degrees of freedom is I have 11 data, so 11 minus 2 equals 9. That's my degrees of freedom. And the level of significance is 0.01. Okay, so I'm going to use these two values to find the critical value. So 0.01 and the degrees of freedom is 9. So that's 0.7348. So the critical value is 0.7348. Okay. Yeah, and because R is greater than this critical value, so our answer should be yes, there is a linear relation. Okay. Yeah, so that's how to find the correlation coefficient using the Google Sheet and how to compare the coefficient with the critical value.